In this video, we're going to look at something called the range rule of thumb and also the empirical rule. If you already know the standard deviation, then you can use that to compute the range rule of thumb. And so this is a set of what we would consider usual data values. And so the minimum usual data value is the mean minus 2 times your standard deviation. The maximum usual value is the mean plus 2 times your standard deviation. So we say that data below the usual minimum or above the usual maximum are unusual data values. So if they fall between these two values, then we say that they're usual. If they're outside of that, we would say that the data value is unusual. If you don't know the standard deviation, then you can use a really rough estimate of the standard deviation, and to compute that it would be the range divided by 4. So let's take a look at an example. So here's just a picture of this idea. These values are significantly low. These values would be considered significantly high, and if you're in here, then we would say that the values were not significant. So these would be our usual data values. These would be unusual. And these are also unusual. We're going to estimate the standard deviation of the height of dogs in the last example that we did, and try to figure out whether a height of 120 millimeters would be an unusual height for a dog. So first we want to compute the range. And the range is the largest data value, which was 600, minus the smallest data value, which was 170. And we want to divide that by 4. And 600 minus 170 is 430. And then divide that by 4 gives us 107.5. And this is millimeters from the last example. We want to compute the minimum and the maximum. The maximum would be our mean, x bar, plus 2 times our standard deviation. So that would be 394 plus 2 times, and we're going to use our estimated standard deviation of 107.5. And if we compute that, we get 609 millimeters, and then compute the minimum. So that's going to be x bar minus 2 times our standard deviation. That will be 394 minus 2 times 107.5. And computing that value, we get 197 millimeters. So this means that our usual heights are between 179 millimeters and 609 millimeters. So if you're outside of that, smaller than 179 or larger than 609, then the data value is unusual. So we can say that 120 millimeters is an unusual height for a dog. Now the empirical rule, so this is the same idea, and so this rule applies for bell-shaped distributions. And so again, this is only for bell-shaped distributions that we can use this empirical rule. And so the empirical rule is 68, 95, 99.7. These are percentages. And so about 68% of all of the data values will fall within one standard deviation of the mean. About 95% of all your data values will be within 2 standard deviations of the mean, and about 99.7% of all of your data values will fall within 3 standard deviations of the mean. So here is just a diagram of this empirical rule, and so this is a nice picture of what you have going on, and so 68% of all your data fall in this area from 1 standard deviation to the right and 1 standard deviation to the left of your mean. And then 95% of your data will fall in this region, 2 standard deviations from your mean. And that's written up above as well. And then 99.7% of all your data is going to be between here and all the way up here. So 99.7% of the data will fall in that area. So now IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. So we want to calculate what percentage of IQ scores are between 70 and 130. So it's nice, I just like to use a line chart for this. And so the mean is right in the middle, 100, and our lower value was 70 and our higher value was 130. So we want to figure out what percentage of all the IQ scores are in between a score of 70 and 130. So if we take this smaller value and subtract that from 100, we get 100 minus 70, or 30, and now take 130 and subtract 100 from it, and we also get 30. Also notice that our standard deviation S is 15, and 30 is 2 times 15, which is 2 times our standard deviation. So this is 2 times our standard deviation, and this is 2 times our standard deviation. And so the percentage of data that will fall between 2 standard deviations of our mean is 95%. The reason that we subtracted these backwards, so I took the mean minus the smaller number here, but here I did the bigger number minus the mean, is so that we ended up with positive values when we did our subtraction. So that's the only reason that I subtracted in that way. So you want to subtract so that your values are positive and you don't have anything negative. So that is it. That's the empirical rule and the range rule of thumb. So let me know if you have any questions, and have a great day. Thanks.